So now that we've dealt with the low-level approach to the lines of code that need to be put in place to read a file, we talked about the components to load in a file. We talked about the logic and the helpers to be able to parse the data. Let's deal with how do we deal with adding I/O to the bigger program. See, the real world is full of tons of ugly data. In a GUI, users can type in any little silly stuff they want to. That's why we add validation. Files, similar, need validation because they can contain any trash that could be coming in. They could be empty. They could be partially complete. They could be screwed up by users who tried to edit them by hand. They could be screwed up by a program that wrote them incorrectly. So, given all that mess, why do we bother? Why don't we just let users type it in and leave it there? Why do we write them out? Well, we have to. We have to write them out. We have to load data back in. If they update my software, I'm going to make patches. I'm going to make upgrades to the services. I need to be able to have new software go read this stuff in. And if I'm reading in garbage, I'm going to get garbage results from my program. So I want to have some components that are smart exclusively in what does that data look like and what should that data look like. I don't want to just look for bad stuff in data. I want to make sure the data is good, but I don't want that to be the responsibility of every part of my program. I don't have to have that be repeatable all over the place. So the best thing I can do is build components that are specifically responsible for protecting our code. So if you remember back, the way we built our system for the user interface is we tried to isolate out the GUI logic from the swing components. And we tried to build other objects that represented the data we had going on. In your application, you probably have a customer object or a product object or something like that that you've gone to represent the data that's out there. And then when we were writing the files, we took that object, we handed it to a component, the I/O code, that would then go and do all the messiness of putting spaces between it and opening files and putting right lines in between them and all that sort of stuff. So we had a separation between the ugly UI code and the pretty objects that were inside of there. We had a separation between the algorithms and work that happened and the stupid I/O code that has to be done. Now, it's good code, it's valuable code, but it's not what most important stuff is here. The most important stuff is the stuff in purple. That's what we get paid for. How do we build data and, buy things, sell things, have games and websites and all this sort of stuff. This stuff up here must be done, but it changes from time to time. I mean, UIs used to be desktops, then they went to computer websites, and now phone apps, and who knows what'll be next. I/O, again, there's files, there's databases, there's all sorts of stuff. So what we want to do is define these dependencies, but separate out the code at a higher level, which then allows us, as we'll see when we get to later classes, to separate out files and then remove them and swap it out with maybe a database or some other way of storing data that's a little bit better. So in Java, we need to protect ourselves a little bit from our own code that we write. The Java virtual machine is not going to let you kill the computer very often. For the most part, you're not going to get blue screens of deaths from Java. Java's pretty good about if you write a terrible program, the Java virtual machine will stop that. But we can do better than this. Ideally, our programs are going to give nice ways of failing, or at least give us log files to know why it failed. We can do better than the ugly errors that Java is going to get, which will basically just crash our program. So that's where we have to come back to exception handling. We can do simple things like at the top level of our program, we create an application, we process some files, and if something goes wrong, we say, hey, our program failed, sorry about that. I mean, we can do better than this even, but we need to at least add our own exception handlers to make sure our programs are running clean, our programs are running well. So anytime we encounter a failure, we have to make a choice. Should we shut down the program entirely? Whatever task we're doing, should we just try it again? Or should we just skip the task and move along? If we have a user interface, maybe we can ask the user, what do we do? And so part of exception handling is figuring out what's the acceptable and the steps we can take. When I'm trying to read in from a file, if that file doesn't exist, well, maybe I try a different file name. Or maybe ask the user what the file name is. Or maybe I just skip that step. Just say, hey, there's no data found. Depends. Depends what your application wants to do. We have to plan for it, but we have to consider what are the requirements of the application and go from there. So one of the options we can do is, like, let's just say we were reading a file and one of the lines in the file was bad. So we have a for loop, a while loop, whatever we have going on inside of here. We have a try catch where maybe we're processing a line of code and something failed. Okay, so we were expecting 4 lines to be 4 data items inside of here. We only got 3. We can't process this one, but it doesn't mean you can't read the rest of the file. So hey, we'll just give you a notice. By the way, one of these lines is bad. Go look at the file later on if you want to. And I keep going. That's one option inside of here. I would use my try catch inside of a loop, and then I can use the continue statement to skip the rest of the loop and move on. Another option we have inside of there is just to force you to keep going until it works. So I have a try catch inside, and as long as there's a failure, my success stays false until it succeeds without failure, gets to the bottom of the try catch statement, and it sets it to true. It'll keep going over and over and over again. So if I am opening a file, I prompt the user for a file name. If the file's not there, I prompt him again for the file name. If the file's not there, I prompt him again for the file name. Something like that. So remember, I can take my try-catch blocks and put them inside of any logic I want to. For loops, while loops, if statements, whatever. I can capture the error in place and be able to come along and be able to pick exactly the right logic, exactly the right code that I need to solve my problem. So this is not by no means the limitation of the way I can place an exception handler anywhere I want to. I can stop the scope anywhere I want to. I can apply the logic anywhere I want to. And so you need to consider that as part of your application design going forward. So how do you choose which one you go to? Well, does the failure, if it pops up, make all the work you did before invalid? If I'm reading a file and my purpose is to total the number of sales from that file and one of the lines doesn't read, well, I can't do that. There'd be a line inside of there that would, maybe it's a big sale, maybe it's a big expense. I have to throw out my whole work. As opposed to if I want to read all the context I have in the file from my voter registry, if one of them doesn't work, it's just fine. I don't want to not contact the rest because one voter's not, the data's not loading. Just say, hey, line 75 isn't loading, and keep going. If a failure happens, can your program recover? I mean, if I can't load a file, can I ask the user for another one? Or if not, I have to stop. Fundamentally, what does the user want from the program? What are they trying to get out of the program? So a quick side note here. You might go off and read about the scanner class. The scanner class is often used for basic I/O, when you're doing command line I/O in particular. The scanner object is not the best class to use for reading files. There's a lot of features inside of there I don't need. I'd much rather use in my logic something predictable. And the tokenizer is a much better way of being able to get data out of that. And taking it and converting the items inside of a token to integers is much better than saying read string, read int, read whatever. It actually makes the data, the processing a little bit easier as well. So things like input.hasNext doesn't apply to files. As you're moving forward, then my recommendation is abandon the scanner object. It's not something, and this is an example that's from, you might have seen from doing command line, but it's not the best thing to use for this. You're going to be much better off going through and learning about and using buffered readers and file readers and things like that than you would be trying to struggle through the scanner. All right, so one other note that we're going to do, and then we'll really be ready to wrap all this into our system. So we want to be able to understand how do we create components and how do we protect those components with proper exception handling. But let's take one high level view of what we need to build before we finish up.